Good morning, students. Our today's topic is Rutherford's model of atoms. Student Ernest Rutherford was interested in knowing how the electrons are arranged within an atom. Rutherford designed an experiment for this. In this experiment, fast moving alpha particles were made to fall on a thin gold foil, as you can see in this diagram. And he observed the scattering of the alpha rays after hitting the foil by placing a circular zinc sulfide screen around the metal foil. And whenever alpha particles strike the screen, a flash of light is produced at the point on the screen. From these experiments, Rutherford made some observation. Like the first observation was, most of the alpha particles passed through the foil without undergoing any deflection, as you can see this diagram. And some alpha particles were deflected through small angles and a few were deflected through large angles. And the next observation was, very few were deflected back, like through an angle greater than 90 degrees. From these observations, Rutherford drew some conclusions. Now the first conclusion was, since most of the alpha particle passed through the foil without undergoing any deflection, so there must be sufficient empty space within the atom. The next, since some alpha particles were deflected through small angles or a few through large angle, and we know that alpha particles are positively charged particles, so these could be deflected only by some positively charged body present within the atom. So the alpha particles deflected through small angles were those which passed close to this positive body, as we know that positive reflection, right? The alpha particles deflected through large angles were those which passed very close to the positive body. Okay. Next conclusion was, since some alpha particles are deflected back and alpha particles are, we know that, heavy particles, so these could be deflected back only when they strike heavier body inside the atom. And since number of alpha particles deflected back is very small, so this shows that the heavy body present in the atom must be occupying a very small volume. And this small heavy positively charged body present within the atom was called nucleus. Alright, so students, on the basis of scattering of experiment, Rutherford put forward a model of atom known as Rutherford's nuclear model. And the main points of this model are, number one is an atom consists of two parts, nucleus and extranuclear parts. Nucleus is a small, heavy, positively charged body which is present in the center of the atom, and extranuclear part means the space around the nucleus in which the electrons are distributed. Okay. The second main point is the entire mass of the atom is concentrated in the nucleus. Since the electrons have negligible mass, okay, so the mass of the atom is mainly due to the proton. Hence, proton must be present in the nucleus. Right? This we have already discussed. Then, Rutherford also explained that the electrons do not fall into the nucleus as a result of attraction. Rutherford suggested that electrons were not stationary but were revolving around the nucleus in certain circular orbits. As a result, centrifugal force comes into play which balances the force of attraction. So students, thus this model is similar to our solar system where the nucleus is like the sun and the electrons are like the planets. That's why these electrons are also called planetary electrons. Now the next thing is, which is really very important, that is the drawbacks of Rutherford's atom model. Student, Rutherford's model could not explain the stability of the atom. This is because, according to Rutherford's model, an atom consists of a small, heavy, positively charged nucleus in the center, as earlier we have discussed, and the electrons were actually revolving around it, right? So, however, whenever charged particles like electron is revolving around central force, okay, like which we have in nucleus, it loses energy continuously, okay, in the form of radiation. This we know in physics also, we have studied about this. So thus the orbit of the revolving electron will keep on becoming smaller and smaller, right? So following a spiral path, it will become more smaller. So what will happen, ultimately the electron should fall into the nucleus. In other words, we can say the atom should collapse, right? So however, this actually does not happen, and the atom, we know that it is quite stable, but actually this was the big drawback of the Rutherford's model of atom.